Dr. Rupert Sheldrake, on behalf of the three Baldwin brothers, Ian and Michael and Philip Baldwin, welcome to the Three Brothers Quest.
Thank you.
And thank you for hosting us here in your beautiful home. So, can we start with morphic resonance?
Mm-hmm.
What is morphic resonance?
It's an influence from the past based on similarity. And basically what it says is there's a memory inherent in nature. And in the most general sense, the so-called laws of nature are more like habits. So normally we have the view that nature is governed by fixed laws that were all there at the moment of the Big Bang and haven't changed since. And I'm saying, no, it's not like that. The nature is governed by memory that builds up within it. And the basis of the memory is similarity of self-organizing systems. So morphic resonance is the process by which the past influences the present on the basis of similarity. So this applies to crystals, molecules, cells, tissues, organs, societies, families. It applies to many, many self-organizing systems.
The New York Times crossword puzzle doers?
Yes, it should be easier to do the New York Times crossword puzzle tomorrow than today's puzzle, because so many people have done it.
I heard you reference that, and that was just so astonishing to me. Wordle as well, for all of our New York Times crossword puzzle viewers. How does that work?
Well, if a lot of people have confronted a particular problem, trying to solve it, then when subsequent people confront the same problem, there's a kind of resonance from those who've done it before, which makes it easier to solve. And there's a long series of experiments with rats that started at Harvard years ago, where they were trained to escape from a water maze. And they got quicker and quicker at doing it in subsequent generations. And then when people tried to repeat this in Australia and in Scotland, their rats took off, they took it up where the Harvard rats had left off. They were doing it about 10 times quicker than the Harvard rats had to start with. And they went on getting better. And it wasn't just ones who had been descended from trained parents, but all the rats of that breed. Now that's what I would call a morphic resonance effect. Another example in the human realm is with IQ tests. In the 1980s, when I was first thinking about these things, I predicted that IQ tests should be getting easier because so many people have done these standard tests over the years. So the average scores should be going up, even though people aren't actually getting any smarter. And this was actually discovered by a psychologist called James Flynn. It's now called the Flynn effect. There's been a more than 30% increase in average IQ test scores all over the world. And psychologists have struggled to explain it. At first they said, well, it's gone up in Japan because they're eating more protein, but in America it went up and they weren't eating particularly more. They'd always been eating a lot of protein. Then they said, well, it's because people are being exposed to more TV is making them smarter. But then there other evidence suggested TV is actually not making people smarter. And so on. There's all sorts of explanations have been tried. But the one that really fits best is morphic resonance.
And for lack of a better term, what's the mechanism? It's electromagnetic?
No, it's not electromagnetic, because first of all, if it were electromagnetic, it wouldn't work from the past. Because, electromagnetic waves, like radio waves, travel at the speed of light. And, once they've traveled, they've traveled. Like if you have a smartphone broadcast, it's a radio effect, on a smartphone conversation, you can't pick up that conversation as a memory years later. It happens in the present. So does quantum non-locality, which is another phenomenon that's a bit similar. That happens in the present. So what I'm saying is a bit like a radio transmission, but it's coming from the past. It moves across space and time. Now, how that works is not part of existing physics. this is a controversial hypothesis because it doesn't fit into physics as we know it. But there are various people in theoretical physics who think that morphic resonance would fit with extensions of quantum theory. The late David Bohm was quite keen on morphic resonance, and he thought that it moved into what he called the implicate order, an order beyond time and space as we know it. A British theoretical physicist, Bernard Carr, points out that in superstring theory, which has 10 dimensions, or M theory, which has 11, these are mainstream theories in theoretical physics. I mean, about 80% of theoretical physicists work on them. So they have all these extra dimensions. And he thinks these extra dimensions could actually be doing something, that they're actually, it could actually enable similar things to connect across time and space.
It's amazing. How did you, for lack of a better term, discover this idea, this concept of morphic resonance? You mentioned the 1980s.
Well, actually, I first thought of it in the 1970s. I was a fellow of Clare College, Cambridge, and I was doing research at Cambridge on the development of plants. And I discovered how a plant hormone, auxin, chemically it's called indole acetic acid, this plant hormone, I discovered how it was made, and with a colleague, how it was transported around the plant. So we were way ahead of anyone in the animal realm in terms of understanding key chemicals in development of plants. The trouble is that although we were ahead of anyone else at the time, in a way it explained too much, because the same hormone is present in the leaves and the flowers and the roots. It's present in ferns, it's present in conifers, it's present in flowering plants. So it's present in all those places, and it doesn't really explain the forms. It explains how they're coordinated. It's a bit like money. You know, money is everywhere. There's not much money. You know, if you look at the physical amount of money in a banknote in your pocket, it doesn't bear much relation to things you can buy with it. And yet it flows around and causes all sorts of things to happen. And yet it's not, although the flow of the money is important in understanding the economy, it doesn't explain the architecture of the houses that are paid for with money, or all the different products in the supermarket that you can buy with money. Something else has to be causing the form. And within developmental biology, since the 1920s, there'd been the idea that forms were shaped by morphogenetic fields, form-shaping fields, which are a bit like invisible plans or blueprints. So a leaf of a particular species would be shaped by a leaf-shaped field, and a flower by a flower-shaped field. So like invisible molds or blueprints or plans. But they're not proteins. Proteins are part of the materials within plants, and DNA, the genetic material, codes for proteins, the structure of proteins. So how could DNA, genetic DNA, code for the shape of a flower, the shape of a leaf, in a rose, for example, or the shape of the spines, the thorns? Well, it can't. And so the idea was that there are these fields that shape these things, but biology is evolutionary, forms evolve. So how could they be inherited? So I was wrestling the question, how could morphogenetic fields be inherited? They can't be crammed into genes, because genes code for proteins, and proteins are molecules. They're not structures or patterns like the shape of a rose flower or a rose leaf or a beetroot. They only code for proteins, so something else has to be underlying the inheritance of morphogenetic fields. I was wrestling with this problem for months, and then I suddenly realized that if there was a direct connection across time based on similarity, they could be inherited direct. And that's where I got the idea of morphic resonance. Morphic means form in Greek. Resonance works on the basis of similarity. Acoustic resonance works on similarity. Radio works on resonance. You have a particular frequency, that's why you tune your radio to a frequency. Mobile telephones work on resonance. Electron spin resonance and nuclear magnetic resonance used in medical imaging. These are all different resonant phenomena, and all of them are based on similarity. So this idea is there's a kind of resonance of form across space and time, but not just form, it is the form within a self-organizing system. So this wouldn't apply to, say, a machine, because a machine's not self-organizing, made in a factory. That's why we have factories. But proteins are self-organizing, molecules are self-organizing, atoms are self-organizing. You don't assemble a zinc atom in a laboratory or a factory. It's just there in nature, and you mine it and purify it and stuff. So this applies to self-organizing systems, which is much of nature: crystals, plants, animals, ecosystems, planets, stars, galaxies.
So then rats of a similar species are learning to do the maze faster because, informationally speaking, there is a resonant frequency that informs those rats over time.
Yes, but it's not exactly a frequency, because what it is the whole pattern of resonance. You see, a radio wave you can collapse down to a single frequency or a sound wave, but if you have something like a symphony and a symphony orchestra playing a symphony, it's not a single frequency. It's a whole range of frequencies. And in an organism like a rat, you've got a whole range of frequencies. You've got the heartbeat, you've got the brainwave frequencies, the frequency of proteins, the breathing rate. There's a whole lot of different frequencies organized in a particular form. It's the whole thing that resonates, not just a frequency.
I like your metaphor of a symphony. That helps me make more sense of it. How has your idea of morphic resonance been received by the scientific community?
Well, the scientific community is not a uniform body of people. There are different branches of it and lots of different individuals within it. I worked in India for years. I worked at an agricultural research institute. And when I talked about this idea to Indian scientists, they absolutely loved it, because morphic resonance is very similar to the Hindu idea of karma, the influence of the past. Hindu and Buddhist cosmologies have a memory in nature. It's an unusual idea in the West, but it's part of their traditional way of thinking. So there are all sorts of Hindu texts about memory in nature. And the Theosophists, who derived their idea from Indian and Buddhist thought, talked of the Akashic record, a kind of cosmic memory bank. So when people in India loved it, when I spoke to Jungian psychologists, they loved it. It fits very well with Jung's idea of the collective unconscious, the collective memory, because morphic resonance says that every species has a collective memory, not just humans. Whereas the Jungians have been saying this about humans for years, but they've been rejected by normal biologists by saying there's no way this could be coded in DNA, which is true, it couldn't be. So they say it's a pseudo-scientific concept. So they loved it. Some scientists were very curious and interested and open-minded, but there was a subgroup of scientists who were violently opposed to morphic resonance, and that subgroup, who are still opposed to it, I would say the common feature they all have is that they're very committed to a materialist worldview. And most of them have actually been militant atheists. People who've made a materialist worldview the center of their whole personal identity and belief system. And they think that the nature is governed by fixed laws, there's things like the collective unconscious of Jung couldn't possibly happen. And so they have a worldview that excludes the possibility of morphic resonance. So they think it's simply impossible, and therefore it must be pseudoscience. And there are organized skeptic groups who defend that worldview. Some of them have captured Wikipedia, or the parts of Wikipedia that deal with psychic research, alternative medicine, and people like me. So if you read my Wikipedia page, you'll see it's written by a group of people who are determined to put me in the worst possible light, because they're very opposed to any idea that goes against standard materialist dogma. So there's a variety of responses in the scientific world. So there isn't a scientific community that has a uniform view.
Yeah, fair enough. Do you think the idea of morphic resonance, is gaining traction in this moment we find ourselves in? Is there more curiosity, is your sense?
Yes, I think so. And the dogmatic materialists are, I think, losing traction at the moment.
Yeah.
I mean, take a typical example of someone who's violently opposed to morphic resonance and the other kind of research I do, Richard Dawkins.
Yeah.
Well, you see, many people would, I think, nowadays see that his views are somewhat dogmatic and narrow, and less credible than they used to be. I mean, within the realm of evolutionary theory, for example, the dogmatic neo-Darwinism that he espouses, all in the genes, is giving way to a much broader picture of evolution with epigenetic inheritance, the inheritance of acquired characters, which has now been rebranded epigenetic inheritance. All these former heresies are now mainstream again.
Yes.
And so luckily, the intellectual climate is getting broader and more inclusive and less dogmatic.
That's encouraging. So before we move on from morphic resonance, what are the practical implications, shall we say, of morphic resonance for ordinary humans who aren't inclined to think deeply about these matters but are curious? Is there an application? I'm not sure if I'm asking the question quite right, but...
Well, there could be. I mean, the main application could be in education, because if morphic resonance means you can learn things more easily that have been learned before, then it would mean that if you can harness morphic resonance in educational systems, you could speed up learning. I mean, this is happening anyway. I mean, it's people who've studied the rate of acquisition of skills like skateboarding or windsurfing or practical skills or even computer programming have found that people are getting better and better at doing them. They're learning quicker and quicker. And of course, other things change. There are better designs, better teaching methods. So it's difficult to get clear-cut evidence from the real world. But I think that one could design educational systems that optimize morphic resonance and make it happen more, and therefore give accelerated learning. That would be one application. If one could design computer systems that have morphic fields within them, then you could have a completely new system of communication based on morphic resonance and memory storage around the world. Now, present-day digital computers are not going to do this because they're determinate and they just wouldn't leave scope for morphic resonance. But analog computers and possibly quantum computers might show these capacities. So there's a possible technological application, but that would depend on the continued development of quantum and analog computing systems. Computers were often analog in the 1950s, but then digital computers took over and they now dominate everything. And AI and everything is all based on digital computers, which I think will exclude morphic resonance and won't be possible through those systems.
And Is that because digital computers are comprised of binary codes, ones and zeros? Uh, can you explain
Yes,
that relationship?
there are 2 points. First is that morphic resonance works through what I call morphic fields, which are top-down causes. You know, the morphic field of a leaf is a leaf shape covering the whole leaf. It's a field, and fields are top-down causes, not bottom-up causes. So the prevailing ethos of biology for the last 40 or 50 years has been molecular biology, trying to explain life from the bottom up, genes and molecules, little bits, and it's, you know, and explain the whole thing. It's like trying to understand a building like the Empire State Building by understanding the chemistry of concrete and reinforcing steel. I mean, you need to understand that because you wouldn't be able to build it without concrete and steel. But it doesn't explain the architectural plan. So I think that whereas we now know a huge amount about genomes and the genetic code, the human genome is fully sequenced. But when people were preparing, you know, getting excited about the genome project in the 1980s and 90s, they thought once you've got the genome, you've explained human nature, you've got the molecular basis. Actually, it's not like that at all. And all these genome companies that came out with such high hopes, like 23andMe, you know, filed for bankruptcy a few weeks ago.
Yes.
The genome is far less predictive than it was expected to be. You can only predict a fairly small percentage of proneness to diseases or even height on the basis of the genome. It's revealed what is called in the biological trade the missing heritability problem. In other words, a great deal of inheritance is not explained by genes, and this has been revealed by the Genome Project. Now, I think that's because a lot of it depends on morphic resonance. So top-down causation is the key. Now, digital computers don't work. There's a program which is a kind of top-down cause, but the way that they work is through granular digits, plus and minuses. And it's whereas analog computers work with the whole pattern, you know, the whole pattern of what's happening. So a field, like a field. I mean, for example, if you wanted to compute with a digital computer, what happens when you throw stones into a pond? You throw the stones in, there's ripples spread out, and you throw another stone, there's more ripples. If you try to compute that by understanding water molecules and sort of working up from equations of, you know, it would be very complicated to do that. Whereas with an analog computer, the simplest analog computer for a pond would be to make a model pond and throw stones in and just look at the ripples. Then you'd see the whole thing as a whole.
Yes.
Rather than trying to granulate it and break it down to little bits and then build it up again. So you see, I think that in an analog computer, or like a quantum computer, is like an analog computer. You've got superpositions, lots of quantum possibilities superimposed as a whole, and then you get a pattern emerging from that. It's not building it up from little bits, it's working down from the top, as it were. So I think that's how morphic fields work, and morphic resonance works through morphic fields. So first of all, it's holistic. Secondly, the way these fields work, according to my own hypothesis, is by imposing a pattern on otherwise random events. So if you have cells in a developing organism, if you take the cells out of the organism, the cell can divide that way or that way or that way or that way. It can divide in all sorts of directions. But when it's in an organism, like a growing plant, it will divide in the right way for its position in that organism. So out of the many ways it could divide, it just divides in this way. So something is imposing a pattern on what would otherwise be indeterminate or probabilistic. And quantum phenomena are like that too. Quantum phenomena are not rigorously defined, like noughts and ones, and it's always the same. It's a whole pattern which you can only predict in terms of probability. So morphic resonance works through morphic fields which impose patterns from the top down, on what lots of things could happen, but they make this thing happen by imposing a pattern. So, if you have a lot of kids running around in a playground, more or less at random, and then you suddenly tell them you've got to form two teams and they're going to play football and stuff, then they're arranged into two groups, and now there's this whole set of rules, the rules of football,
Yes.
that would cause them to move in particular ways. They could move in any direction, but once they're in a team on a football field, following those rules, there's a top-down pattern, the rules of football, that's over and above each individual child who's playing, which imposes an order on what would otherwise have been random. Now, digital computers don't work like that, because everything is predictably determinate. And even when they have so-called random inputs, the random inputs are usually made by a pseudo-random algorithm that creates a sequence of numbers that look vaguely random. They can look very random, but the fact is they're determined by a program. They're not really random. You can get random event generators which work on quantum noise. REGs, they're called, random event generators. But those are very rarely used in computing. They use pseudo-random algorithms. So it's deterministic and it's bottom-up rather than indeterminate and top-down. And that's why I think machines are some of the few things in nature that don't work by morphic resonance. And the whole of mechanistic science is based on treating the machine as the principal paradigm or model for all of nature. People say, what's the mechanism? Or it's the prevailing paradigm is called mechanistic materialism. And when science got going in the 17th century, modern science, it was called the mechanical philosophy. Nature's a machine. Nature's like, the universe is like clockwork. It was their first metaphor. They've updated the machine in the 19th century, thermodynamics, the movement of heat, where it took the steam engine as the kind of basic model. Now it's the computer. But basically, it's a way of thinking of nature as a machine, and machines simply don't work by morphic resonance. So thinking of nature as an organism and plants and animals as organisms makes it easier to see how they really are organisms, and they may well work by morphic resonance.
Yeah, your metaphors and analogies are so helpful, Rupert. Thank you. Can we pivot to the question of consciousness? The brothers were curious about consciousness, and I know many of our listeners and viewers are familiar with what is popularly called the hard problem of consciousness. You have an interesting understanding of that.
Well, where does one begin? Well, there are several points here. First of all, we have to acknowledge the prevailing position, which is still what's taught in universities, in psychology departments and most philosophy departments. The idea that there is materialism, that's the prevailing philosophy. The only reality in the universe is matter or physical stuff. And minds are made out of matter. Matter's unconscious. The whole universe is unconscious. There's no consciousness out there. There's certainly no God out there as a conscious being. There's just matter moving according to eternal laws and constants, propelled by energy. So that's the materialist worldview. And our brains are made of matter. Matter's supposed to be unconscious. And that's why there's a hard problem, because we're conscious. So some materialist philosophers try to pretend that we're not conscious. People hold down jobs in prestigious universities for an entire career by arguing we're not conscious. Others manage to maintain a whole career's worth of philosophy by maintaining that we are conscious, but consciousness doesn't do anything. It's an illusion. But their critics point out that this doesn't really explain it, because illusion is itself a mode of consciousness. So it's a kind of circular argument. That's why it's called the hard problem. It won't go away. And And so I think in dealing with the heart problem, there are several points. And the first point, I think, is that the assumption that it's all inside the brain is incredibly questionable. And so I think when we come to discuss something completely uncontroversial like vision, everyone agrees we can see. Take a simple everyday phenomenon like right now, I can see you, you can see me. So what's going on? Well, the official view is that when you see me, light is reflected from me, goes through the electromagnetic field, enters your eyes, inverted images on your retinas, impulses up the optic nerve, and then patterns of activity in your brain. All that's true, and we can know much more about the activity in the brain than ever before, thanks to scans. But all that does is explains activity in the nervous system. How come you actually see? Well, that's the hard problem, the fact you're conscious of what you see. But then the second problem is, when you're seeing me, where are your images of me? Now, the official view is that somehow, mysteriously, in an unexplained way, the patterns of activity in your brain generate a representation of me and of everything you see around you, which is inside your brain. There's a little Rupert somewhere inside your brain, a representation of me and of this room, and it's all inside your brain. Now, how that arises as a virtual reality display from nervous tissue is completely unexplained, but is taken for granted by lots of very smart people in universities who think they must be right because materialism must be right. They can't explain it, it's paradoxical, but they believe this. Now, what I think is something much simpler and easier to understand, which is that all these changes do indeed happen in our brains, but when we form the images, they're not inside our heads, they're where they seem to be. So I'm projecting out an image of you, and my projection is located right where you are. It's in my mind, but it's not inside my brain. And everything else I'm seeing in this room, I look at the mantelpiece behind me and the ostrich egg and so on, all those images are where they seem to be. And if I look out of the window at trees, the images of the trees I'm seeing are where they seem to be. If I look at clouds in the sky, those images are where they seem to be, up in the sky. And if I look at stars at night, the images are literally millions of light years away. So the images, I'm saying, are projected out to where they seem to be. That vision involves coupling our consciousness to light in such a way the images are projected out. And sometimes they're projected to where things aren't, and that's where you get an illusion. And sometimes you project them when there isn't a basis in the outside world. That's a hallucination. But normally our images are projections, and some psychologists, like the British neuroscientist Anil Seth, who's completely conventional materialist, would say that our normal perceptions are controlled hallucinations.
I've heard him say that.
Yes. Yeah. So I like that idea. I think it was quite a good way. They're projections, and if they're not controlled by the sensory input, then we get just pure hallucination. And of course, when we're dreaming, or if we have our eyes closed, or if somebody's having a psychedelic experience with their eyes closed, all that imagery and everything they're seeing is, kind of projection. But in visual perception, the projection is coupled to the incoming light, so that the projection coincides with what we're looking at. So I would say that when we look at something, in a sense, we touch it with our mind. Our mind reaches out to touch it, which is why I'm interested in the phenomenon of the feeling of being stared at from behind, which is technically known as scopaesthesia. Scop as in microscope, seeing, and aesthesia, feeling, as in anesthesia, synesthesia. So scopaesthesia is incredibly common. About 95% of people have experienced it. It's common in animals. Most people have had the experience. You turn around, you find someone staring at you from behind, or you stare at someone and they turn around. It happens with dogs and cats and animals. It's not specifically human. And the reason it happens, I think, is because when we look at something or somebody, our mind reaches out to touch what we're looking at. Therefore, we can affect that what we're looking at. And people can pick this up, or animals can pick it up, and it's directional. They turn and look straight, usually at the person looking at them.
Yeah. When you say our mind reaches out, can you unpack that a little bit? It's so beautiful.
Well, I think that we have literally visual fields. That I think that when I see you, I think there's a field that it's like the reverse of the light coming in. The light that comes in is in the electromagnetic field, which is spread out through the whole room. Now, that's standard physics in textbooks. I mean, most people may not think of it that way, but it's not controversial to say that I'm seeing you because I'm seeing you through the electromagnetic field of this room. And that field isn't just unstructured, it's highly structured with the light that's reflected from you and reflected from everything else gives a structure to that field. And I form an image through my lens and pattern on the two-dimensional projection of the field on my retina. But I think that vision involves a kind of reverse flow. So our visual projection is like going the opposite direction to the incoming light. So our minds, I'm saying, are projected out. What I'm saying really is our minds are fields. They're not things inside the brain. They're fields that extend beyond the brain. They're in the brain, but they're beyond it as well. Like a magnetic field is inside the magnet, but it's also around it and affects what's around it. The Earth's gravitational field is inside the Earth, but it invisibly stretches through this room. We're both in it now. And it goes to the moon, keeps the moon in its orbit, and it even affects the sun through a tidal pull on the sun.
Wow.
So we're completely familiar from standard physics with the idea of fields that are extended beyond material objects. And I mean, after all, radio waves and mobile phones depend on that. The reason mobile phones work is because they have electromagnetic activity inside them that sets up electromagnetic fields or vibrations in the field which transmit impulses and receive them. So that's why they work wirelessly. It's all field technology. So practically all our modern technologies depend on fields. So what I'm suggesting is our minds are field-like, whereas you see most materialists have a kind of 19th century or even 18th century view of matter as just stuff that's located, like billiard balls and things. But even in the 18th century, people knew that gravitational influences stretched out beyond material objects. So, but they've got the idea that if it's material, it's got to be inside the brain. Now, it's not that radical to say the mind might be field-like, stretched out beyond the brain, and that's how vision works, because fields are not an alien concept to science. They're the very basis of modern science. Quantum matter fields, electromagnetic fields, gravitational fields, all of them are different from each other. And if you say, well, what is a morphic field? You could easily say, what is a gravitational field and what is an electromagnetic field? And Einstein spent decades of his life trying to understand what it was and how the fields related to each other. He was on a quest for a grand unified field theory, how these different fields are related. And superstring and M theories, which I mentioned earlier, which have 10 and 11 dimensions respectively, are attempts to explain the fields of nature in terms of a super multi-dimensional field that sort of gets curled up or contracted into the fields of nature we know. But it's a theory that's untestable and, it's speculative. And so what are fields? There's no simple answer.
Yeah, wow, so much to ponder there. Can you talk for just a bit about you are a man of science, Rupert, and you are a man of faith. And I think the brothers and I were curious about how you balance those two, being both a man of science and a man of faith. And you've been doing this and talking about this for quite some time.
I don't see a problem myself. I mean, there is a problem if you're a materialist. If you believe that science equals materialism, then you have a really big problem. A lot of people do believe that, because materialism is inherently atheistic. Materialism, as I mentioned earlier, says that the only reality is matter or physical processes and physical reality, and it's unconscious. So if the whole universe just works automatically on the basis of mechanical laws and what's already there and pushing and pulling and so forth, and there's no consciousness anywhere in it, there's no God out there, no spirits, no angels, no dead ancestors, spirits, or anything like that. So from that point of view, the sort of Richard Dawkins point of view, or the Daniel Dennett point of view, if we take these prominent public materialists and atheists, then the religion is just make-believe and God is just a fantasy inside human heads, just something produced by our imagination, and the only people who believe in it are people who are stupid or who've been indoctrinated or whatever, or feeble-minded or desperately need the consolation of religion or so on. Whereas materialists are tough, strong-minded individuals who fearlessly look at this depressing truth of a pointless universe going nowhere, with nothing out there except matter, purposeless matter. Well, that's the usual view, and that's the view that most educated intellectuals are brought up to think of as the scientific worldview. But actually, as I show in my book, The Science Delusion, in America it's called Science Set Free,
Yes.
Materialism is based on 10 principal dogmas, each one of which is simply an assumption. It's a dogmatic assumption. And it's held by materialists with a firm, unwavering belief in authority. All the things they accuse religion of applies to dogmatic materialism. Most people accept it on the basis of authority. Most people haven't worked at the Large Hadron Collider for years to penetrate the inner recesses of matter or stuff. They believe what they read in science journalist reports in the New York Times or in Scientific American or something. They haven't personally investigated it. And if some eminent professor comes along and gives a statement on television, then the authority, it's like people believing what the Pope or a cardinal says. These are the cardinals of science. So first of all, it's believed on authority. Secondly, it's something that's just based on assumptions. And thirdly, if you question these assumptions, which I do in my book, The Science Delusion or Science Set Free, people simply can't defend them. I mean, when journalists tried to find materialists who debate these points with me when my book came out, none of them were prepared to engage.
I wondered about that.
Yes, they just say this is ridiculous, this is rubbish, and these arguments are discredited or something like that. But trying to brush it off with contempt. But it's a defenseless position in present. I mean, it's maintained by a tremendous force of habit, and by organized groups of activist skeptics, the so-called Committee for Skeptical Inquiry, and people with their Wikipedia teams and so on. This is an organized movement based on, reductionist, dogmatic materialism. But if one sees that science is not, those assumptions are not science, the idea that matter is unconscious, the whole of the universe is made of unconscious matter, that's just an assumption. In the 17th century, Descartes, the French philosopher, said all matter is unconscious and all consciousness is outside matter. Spirit, God, angels, spirit, and the human mind are not material. They're beyond time and space. They're transcendent. So he split the world into consciousness and unconscious matter. Then in the 19th century, the materialists said, "Oh, we don't need all this God and angels and all this stuff about human minds being transcendent, mysterious. You can't measure it, you can't touch it, you can't define it. So that just doesn't exist. So we've just got matter, nothing but matter." But because the hard problem is such a hard problem, increasing numbers of philosophers are now saying, well, maybe there is consciousness in matter. Maybe even electrons and atoms have a little bit of consciousness and molecules a bit more. And so when you get to human brains, a higher level of consciousness could emerge, not from no consciousness at all, but from lower levels of consciousness. So panpsychism, the idea that consciousness is spread through nature, is now actually widely believed among academic philosophers. It's perhaps surprising this has become so widespread. It's because of the hard problem. And moreover, the philosophy of idealism, the idea that the ultimate reality is conscious, not material. Instead of saying that consciousness is just produced by matter and doesn't do anything, which is the materialist view, the idealist view, says that matter is kind of dumbed down mind and consciousness is primary. So these are all actual areas of discussion and debate right now. So any religious view is essentially idealist. Any religious view takes the idea that the ultimate reality is conscious. Brahma, Allah, God. Their primary characteristic is consciousness. That's what they are. And when God in the Old Testament announces himself to Moses, he says, "I am who I am," conscious being in the present. So the primary attribute of God is consciousness. God's not an object you see out there with a telescope or can't see out there with a telescope. Just like our consciousness can't be seen with a microscope or with a brain probe. All you see is nervous tissue, brains, skulls, bodies, etc. You don't see our consciousness. So it seems to me the idea there can be consciousness beyond the human level is extremely plausible. And what's the evidence? Well, the evidence, I think, for all religions starts with the direct experience that our consciousness is part of something greater than ourselves, which a mystical experience. I mean, that's where Buddhism starts from. Buddha didn't become enlightened by doing a PhD in neuroscience. He became enlightened through meditating under trees and achieved this state of insight into the nature of consciousness. And Jesus didn't become inspired through rabbinical seminaries, although he knew his Bible well enough. But at the moment of his baptism, he had this transformative experience, a kind of mystical experience of his union or connection with God, his relationship to God. So now it turns out mystical experiences are much more common than people used to think. And millions of people have had them. And lots of people have them spontaneously. Some have them through near-death experiences. Some have them in childhood as a sense of revelation of something vastly greater than themselves. Some have them through psychedelic experiences. So the main reason that people believe in God is not because they've been browbeaten or indoctrinated. Well, maybe some have. But the reason that most religious people have become religious in the first place is because of experiences of being part of a consciousness greater than themselves. Now, materialist science may say rubbish or nonsense to that, but have they got a better theory of consciousness? Can they explain these things better? The answer is they haven't got a theory of consciousness at all. All they've got is a dogma that says consciousness doesn't exist, or it's nothing but a meaningless epiphenomenon of the activity of the brain. So it's not as if they're on very strong ground when it comes to this. So I think the idea of a consciousness greater than our own, which underlies all religions, is at least as plausible, in fact a lot more plausible than the materialist worldview, and less dogmatic. Because, if you look at religions, if you get into the idea of consciousness beyond the human level, there's not just one view, there's lots of views. There's Buddhists, there's Hindus, Christians, Muslims, Sikhs, and so on, shamanic cultures with their own interpretations, and all these different views, and within each religion, different, Greek Orthodox, Roman Catholic, Anglican, Baptist, etc., there's Sunni, Shia within us, large range of different views and interpretations. Whereas when you get to materialism, there's a kind of dreary uniformity and extreme dogmatism.
Yeah, it seems like a very impoverished view of life and the universe, the cosmos. Well, I know we're almost at time, and I just wanted to recommend or celebrate 2 books you've written called Science and Spiritual Practices, and we can maybe save that perhaps for another conversation, but I've found both of those books incredibly empowering, and I know many others who have as well.
Science and Spiritual Practices and Ways to Go Beyond.
Ways to Go Beyond.
Work, yes.
Which I just recently discovered, your second list.
Yes.
Which is astonishing, yeah. But maybe we can end here. I've heard you, Rupert, talk about meditation and prayer and the flow of the breath, a single breath through the body. And the word spiritual comes from the Latin spira, spiritus, which means breath. And this is a very personal question, but can you just speak for a moment about kind of the inhale, the exhale, and how you understand this?
Well, in my book, Science and Spiritual Practices, what I show and Ways to Go Beyond and Why They Work, each one looks at 7 different spiritual practices. And what I show is that when you actually use science to look at what's happening in religious or spiritual practices, what you find is that these practices have measurable effects. One overall effect is that people who have them are, generally speaking, happier, healthier, and live longer than those that don't, which is one reason I think that militant atheism should come with a health warning. Because what it does is it turns people against their traditional spiritual practices, and all it offers them in return is a rather empty feeling that I'm smarter than everyone else. I've seen through all these illusions everyone else is subject to. Of a kind of smug arrogance. So it's a pretty poor deal, in my opinion. Anyway, what I do in these books is look at these different spiritual practices, and meditation has now had a great deal of research on since the 1970s, showing its physiological effects, heartbeat, blood pressure reduced, reduction of the default mode network in the brain. And so this has many effects, and prayer also has many beneficial effects on the person who prays. Now, exactly how it works and whether or not it works all the time, well, it doesn't work all the time, but in terms of when people ask for things, sometimes they happen, sometimes they don't. I'm now talking about the effect on the person praying. I discuss both of these in my books, and I compare them, as you say, to breathing in and breathing out. You see, I think meditation is like breathing in. What you're doing is, in many cases, you shut your eyes, you try and be in a quiet place, and then you concentrate either on your breathing or sensations in the body, mindfulness meditation, or on a repetitive mantra that you say silently. And both ways involve detaching you from your normal activities and from your normal pattern of thoughts, because by having another focus for your attention, it relativizes the internal dialogue or internal train of thought or rumination, which is produced by the default mode network, which is this network of areas in the brain concerned with this internal dialogue. So you then sometimes reach a state where you feel a connection with a consciousness greater than your own, a still greater kind of consciousness, a peace, a connection with something far greater than yourself. Now that's I compare to breathing in. Now prayer, I'm talking here of petitionary prayer, which is where you ask for things, which is the commonest kind of prayer, sort of everyday prayer. You start with an invocation to a higher being, Our Father who art in heaven, Hail Mary, full of grace, Om Namah Shivaya, O Allah. You start with an invocation to a greater consciousness or being than your own. So you connect with it first through an invocation, then usually by being very polite and saying nice things. Hallowed be thy name,
Yes.
thy kingdom come.
Thy will be done.
Thy will be done.
Yes.
And then you move on to asking for things. Give us this day our daily bread. Or in the case of the Hail Mary, Holy Mary, Mother of God, pray for us now and at the hour of our death. So asking Mary to pray for us now and when we die. So, I say the Hail Mary every day. I think we need all the help we can get when we're dying. And so
Yes.
I'd be very happy if Mary helps me when I'm dying. So in these prayers, you start with an invocation, a connection with a higher form of consciousness, and then your attention moves outwards towards problems or situations in the world, things you're afraid of, you want protection from, things you need. Maybe you're in debt, maybe you need some money, maybe you need food, whatever you need, or healing, asking for what you need and for what other people need, praying for other people. So these are practical ways in which you reach out into the world with these intentions coupled to this spiritual source, which is why I think of petitionary prayer as being like breathing out and meditation is like breathing in. And I personally do both. I meditate every morning. I meditated this morning, for example, and I pray every evening before I go to bed. So I think the breathing in and breathing out helps to show that both are necessary. You can't just breathe in, you'd explode. You can't just breathe out, you'd implode. So you have to breathe in and breathe out. And I think meditation is very beneficial in connecting us with, the source, the kind of something beyond ourselves that's a reality that's calm, peaceful, and beyond ourselves. And it's really important to have that connection. But I think petitionary prayer is also very important because it couples our spiritual life to the practical problems of living in the world.
Yes.
And there are some people who are so spiritual they're just hopeless at dealing with living in the world. And there are some people who pray and they're very practical about helping others and getting on with it, but don't have that sort of inner connection with the spirit that would come from more contemplative practice. So that's why I think we need both.
It's so beautiful. The inhale is the meditation, and the exhale is the prayer. Yeah. Well, Dr. Rupert Sheldrake, thank you so much for this conversation. Where can people go to find out more about your work?
Well, first is my website, www.sheldrake.org, which has enormous array of all my scientific papers, links to all my books, lots of talks and things, so a great deal of information. Secondly, I have a YouTube channel, Rupert Sheldrake YouTube, where there's lots of videos of talks and dialogues. And third, I've started a Substack in which I have regular postings of essays, exclusive videos just for the Substack, new videos, and discussions. And previews of my YouTube videos, new ones, previewed on Substack ad-free. So those are the three main ways.
And is the Substack your name?
Yes, Rupert Sheldrake.
Rupert Sheldrake at Substack. And last question, what are you currently working on? What should our audience expect coming up?
Well, one of the things I'm doing is making this new series of videos called Findings, based on various areas of research. I've published more than 100 papers in peer-reviewed journals. And I'm doing a series of talks on areas where I've done research and what I've discovered. The one that's coming out next very soon is called End-of-Life Experiences in Animals, research based on more than 100 case studies of dying animals, many of which show a surge of activity or energy as they die, similar to terminal lucidity in humans, which show a kind of last rally of energy. So that's looking at the dying process. Then I have ones on my work on plants and how the plant hormone auxin is produced. Then I've done one on the polarity of plants, what makes the roots and shoots so different. So these cover a wide range of topics on which I've worked. And otherwise, I'm doing research empirical research on the sense of being stared at. I have a new app that works on cell phones that anyone can try out. And indeed, anyone watching this who's interested, go to my website, look at the Take Part thing in the menu bar, and look at the mobile phone app for the sense of being stared at. Amazing. This is so you can train yourself to get better at it. And I have some morphic resonance experiments going on in a laboratory here in Britain, looking for morphic resonance effects in the adaptation of bacteria, particularly E. coli, to antibiotic resistance. So I'm looking at the evolution of antibiotic resistance, in which I think morphic resonance plays a part. And this could be of practical importance.
Well, thank you so much for all of your work and for taking the time today to talk with us at Three Brothers Quest. Dr. Rupert Sheldrake, and thanks also to the three Baldwin brothers, Ian and Michael and Philip, and of course, our co-sponsor, the Marion Institute. Please support Dr. Sheldrake's work, read his books, they are phenomenal, and we will see you next time. Welcome to the Requesting Room with Michael and Ian and Philip Baldwin. Gentlemen, great to see you three.
Good to see you. Good to see you.
Dr. Rupert Sheldrake.
Yeah.
Let me just say that I so enjoyed that conversation personally, and to be in the home of Dr. Sheldrake and his wife Jill was really quite powerful for me. I don't often fanboy. It's not really in my nature, but it was really nice to be in their presence. So what did you make of our conversation?
Well, that's a nice little way to start, because I think we three thought it was a superb interview. A lot because, to use the word that you use so many times, the flow was lovely. It really was lovely. And it's marvelous the way it unfolded in that there was so little that, in a sense, you had to do, Rob, because he was just so, giving and so easily talking about morphic resonance and the soul and so many other aspects of the science behind morphic resonance. Now, from my point of view, I, of course, think it's absolutely extraordinary, given the amount of research that he's done over a long period of time, how he can be still so debunked by the scientific materialists, and it's a big problem, this intransigence on their part, their inability to, even though it is research, for some reason it's completely disqualified. And I guess because you're dealing with dogs and cats and the blue tit that opens the milk bottle, and the crows and the pigeons and and then these fascinating, more recent ones, I guess, about if you do the crossword puzzle at the end of the day, you're going to do better than at the beginning of the day, because the morphic field around crossword puzzles is going to feed the rest of your field, your morphic field as a human. Same with the IQ test, and I just it really bugs me that there can be such an objection. I guess maybe some of it is cratering of late, but anyway, so I got worked up about the fact that the scientists are so hopeless. And it also made me think about the famous 100 monkey syndrome, 100th monkey syndrome, which we've all known about and chatted about over the years, which to me is another example, a wonderful expression of morphic resonance. Once you get into over a certain number, it spills into, everybody being impacted. And anyway, I think there's something came to my attention recently about certainty, which I brought up with Ian and Philip, and maybe you too, Rob, which is, certainty, such as these scientists who are so dogmatic and so certain that they've got the answer. Certainty is a killer. It's an absolute killer. It destroys creativity. It destroys the sense of mystery. It destroys so much that we all, believe is real and that needs to be embraced for all sorts of valid, beneficial reasons. And I think we've all seen, or most of us have seen, this recent movie with Ralph Fiennes called Enclave, The Election of the Pope. And I love his, very much at the end, Fiennes, as this very important cardinal says, certainty is the great enemy of unity. Certainty is the deadly enemy of tolerance. Faith is a living thing because it walks with doubt. And if only certainty and no doubt, there would be no mystery and therefore no need of faith. And it's, I think, a very pertinent quote. Anyway, I could go on, but I think those are sort of, my main sort of points. And I maybe just one more, which I loved him at the end talking about how a mystical experience proves consciousness. And again, it's such an important aspect of this whole thing. Anyway, that's my take. It was fabulous. It was really fabulous. I hope we can do it again.
Is the problem of consciousness is the problem, and it's called the hard problem. That's what they all call it. For some background, I read this book, Arguing Science, which I don't recommend, but it did do one thing for me. It reinforced, and I should say I've worked with a lot of scientists throughout my life's careers. And so I know science from the sense of knowing scientists. And I don't think they, by no means are they all Dawkins people. But this guy, who is the skeptic whom argues with Sheldrake in this book, Michael Shermer, is what I call a professional defender of materialistic science. And it goes right to what you quoted about from the Cardinal, the movie, which is not absolute certainty, but absolute certainty about the universe. Mm-hmm. It is the most what's the word? Intolerant might be the wrong word, but it's the most absolutist religion ever encountered. Mm-hmm. And so there is no possibility, according to the experimental method, that something called consciousness somehow, in its indefinability and thus lack of certainty, underlies all matter. So it's matter and matter alone.
Yeah.
And we can test it, and we can repeat the findings, and we make a little step forward, and that's how science goes. That's a very crude representation, but yeah, that's it. So I found myself really impatient, but clarified by Schirmer, because I don't know that he's a scientist, but he's a specialist in science. And there are these skeptic societies, skeptic groups, they're like, if you think of a fortress and the columns that come up, the panopticons that come up and look at the landscape and guard the interior, they serve as the residents of the panopticon. No one is going to shake our fortress of certainty.
Very good.
That's a sign. That's an aside. The only other thing I can say is what you brought up earlier, Michael, which is since we have done a little on this show, on this on our quest, haven't we done a little on quantum theory? Yes, we have.
Yeah.
So this whole idea of the field and the fact that in a field, scientific laws don't, as we know them, up to quantum mechanics, don't apply.
Mm-hmm.
The speed of light.
Yeah.
Things happen instantaneously over vast distances. So I think that notion of the field is, I didn't feel like he fully explored it. How could he in an hour? But it's something that I think we would like in the quest, Three Brothers Quest,
Mm-hmm.
to explore with other people.
Yeah. Very good.
Thank you.
Yep.
Well, you both have spoken so eloquently. I'm not quite sure what I'd like to add, but I have a few reflections apropos. I made a note that Rupert mentioned that he has had 110 published peer-reviewed papers. Surely that indicates some overture in the part of the scientific community to his work.
Mm-hmm.
10 peer-reviewed papers, to say nothing of having spent his entire career at Cambridge without being burned at the stake, says that something must be going on. There must be some open portals to have allowed this heresy to happen.
Yeah.
Just a footnote. I would like to follow up the quote, Michael. It's one of those quotes. It would be delightful to re-listen to it because it's a very powerful quote from the Cardinal, so forth.
Yes.
I want to give you an anecdote apropos of what both of you have been saying. I'm quite into homeopathy, and at the same time, I also do all the regular doctor controls and so forth. And when we lived in Switzerland, we had a GP who was the loveliest, sweetest, gentlest fellow. Really a very sweet man, very kind. And I don't remember what the problem was, but we were talking about it, and I mentioned that I was seeing a homeopathic doctor also about this subject. I can only say that he was physically and emotionally transformed when he heard me say this. It's like he kind of morphed into another being and was I sort of went, and so if you build up your house out of straw and somebody comes along with a torch, you're in trouble. And therefore, there has to be radical pushback, which it seems to me is the problem with all fundamentalist approaches to life. The underpinning is doubt or faith, etc., and so on. I wanted to mention, and I'm confused from my notes, he had a wonderful analogy about the Empire State Building. Can any of you recount it? damn it, it was so good. It was a perfect analogy, and I didn't write enough down on my notes, and I'm blanking. But
So, Rob, you know,
Yeah, briefly, he used that analogy to describe morphic resonance. And he said that the actual building, the Empire State Building, does not account for the blueprints, the plans that made the building happen.
Yes.
And I've heard him use this analogy, and he's referenced other architectural and structures as well. But that was it in brief. Yeah.
The cement is not the idea.
yeah, I see. Yeah, good, good.
And I thought that was very powerful. And he went on about also between digital and analog.
Yes.
Digital and analog is a great conversation, and he articulated that most interestingly, I thought.
Yeah.
Anyway, I think my two brothers have been eloquent, so I'm going to shut up.
So have you.
Yes.
All right.
Well, I so appreciate Dr. Sheldrake's time, and again, to he and Jill for making me feel very welcome. And I hope we will have at Three Brothers Quest more opportunities.
Yeah.
Great.
It's an important idea, and I was grateful that he agreed to come on and introduce people to this idea. I know he's a best-selling author and all of that, but a lot of people, if you, possibly including myself, even after listening to your interview, a lot of people don't really know what morphic resonance
That's true.
is. It's not a simple idea.
No.
Yeah, and maybe a good ending place. We're all familiar with Thomas Kuhn's famous book, The Structure of Scientific Revolutions, in which Kuhn argues that there comes a tipping point when the old received wisdom of science gives way to a new and
paradigm,
accurate understanding of what's going on out there.
Yeah.
I really feel, and I feel it even more now, having talked with Dr. Sheldrake, I really feel like he is on the cutting edge of a paradigm shift. In Kuhnian terms, a paradigm shift in both science and also perhaps, Philip, what you remind us we're calling meaning making. Some might call it spiritual, some might call it religious, but how it is that we humans make meaning of ourselves and our flow through this beautiful cosmos of ours. So appreciate the conversation. And we should mention too, Dr. Sheldrake does have a brand new Substack. You can follow his Substack from our Substack at Three Brothers Quest. And we will, of course, put all of those links in this episode's notes when we post across all of our podcast platforms and all of our channels too. So we look for that. And as you support Three Brothers Quest, everyone, please continue or consider supporting the work of our esteemed guests like Dr. Sheldrake.
Great. Very good. Thank you.
I can't wait till our next conversation, gentlemen. Until then, shout out to our sponsor at the Marian Institute and, of course, the three brothers, Ian, Michael, and Philip Baldwin. Thanks to you three.
Thank you, Rob.
See you soon.
Thanks.